All right. Welcome to the basic Raspberry Pi class. This time done virtually. Usually we have it on campus and we have lots of good hardware. So it's the first time we're doing this class remotely. So let me share my screen here. All right, so my name is Chuck Dewey, of course, and we're going to talk all about Raspberry Pi. We're going to first talk a little bit about project and programming, what you need to do as far as when you're thinking about your project, some different options for embedded systems, and then of course we'll talk about Raspberry Pis, the different types. Then we'll go through and show how a typical installation and setup of a Raspberry Pi goes. You can get into some really useful tools. There's a lot of really useful tools out there, and I'd like to really introduce some of these tools to you guys. It makes it much easier to work with in the common environment we have out there. And we'll tour the Raspberry Pi, look at all the stuff on the desktop, how to install packages, and then downloading programs for the Raspberry Pi from the internet. And we'll get into some Raspberry Pi I/O, look at some hotspots and other devices, and then we'll do a quickie I2C bus demo. Unfortunately, I can't do it on as much on your hardware. I have a nice I2C device that I can look at here, so we'll do it that way. So when you're thinking about your project, you know, a lot of projects I've found trying to reach too far, too fast. So when you're thinking about your project, start simple and then improve over time. However, you do want to think a little bit ahead on if you want Wi-Fi or not, or what sort of network connection you might want. Because on some systems, it's easier to add Wi-Fi earlier than add it later. Does your project need analog I/O? Some systems have it already built in. Other boards, you need an add-on. Hardware is only a part of the picture. You know, you can get all the hardware together and you need a lot more time to write and debug the software than it is to assemble the hardware in a system that will work. So just remember that hardware is not the only picture in this. It's hardware and software for your project. And also, whenever possible, have two of any critical piece of hardware. It's always notorious that you let out the magic blue smoke right before the demo. If you have a backup, then you can recover quickly. And of course, the number one rule should be don't procrastinate. I've seen many projects, particularly last semester, that people waited until the last week to try and complete it, and of course, it was very, very difficult to complete their project with good results. Some interesting trends on programming languages. Python has been really taking off in the past few years. And if you look at a lot of the code that I have on the GitHub site, there's a significant amount of Python and C. So it's really not becoming a language, but it's one of the tools that you want in your toolbox. Don't go with one language. The more languages you know, the better engineer you will be. Because if you know C, Java, Python, C prime, then you can learn a lot of stuff and apply it in your future jobs. One good guide, just general guide to different boards. This includes the Raspberry Pis, Arduinos, and many other systems, is the DigiKey Guide to Boards. This is a really good reference if you're just looking at what's out there, but I'll give you a little snippet of some of the types of systems and the advantages and disadvantages. You know, the standalone processor is a really nice thing. It's low cost. There's a lot of EVMs out there. You can get some support from the manufacturer with those EVMs and some example code. However, you need to build your circuitry quite often, and there's not as much open source hardware or software that goes on top of this. So that's one problem. And also, several companies, if you want to program in a higher level language, you have to pay for the cross compiler. The Arduino is very ubiquitous. It's a smaller system. It's got a lot of nice IOs, including analog in. This is very nice. It has a good IDE, integrated development environment. It's got a huge open source community for hardware and software, and the pre-made shields can make it easier to do things. The ADCs tend to be lower resolution and a bit slow. So if you're trying to do any audio processing or VAS processing, they're not so good. And also, this is especially where you want to look in advance to make sure that you select the right one in advance if you want Wi-Fi or Bluetooth. You know, it's tougher to add on the Wi-Fi shield, I found, than to have one already built in. The other thing is it's tougher to get those nice high resolution dynamic displays on the Arduinos. You can get small displays, but not the high resolution dynamic ones. There's some variants of Arduino, like Teensy, SparkFun Artemis, and the Adafruit Playground. They have IDEs very much like Arduino. The Adafruit Playground also has a version that uses MicroPython if you're a Python fan. They're very small, low power, but you know they're a little more difficult to prototype with, and you still have the problems like the Arduino with the slower ADCs, and you need to think of in advance if you want Wi-Fi, Bluetooth. The Teensy and Adafruit Circuit Playground don't have any Wi-Fi connections, of course, but the Artemis is actually a nice little, very, very small device that does Bluetooth, and it's Bluetooth built in. This thing is really small too, so nice little microcontroller. Moving up a little bit is the BeagleBone. BeagleBone is sort of like the Raspberry Pi in a lot of ways. It has a Linux operating system. You can program in many, many different languages on it. You can run the full LAMP stack. That's Linux, Apache, MySQL, and PHP. So you can program in all those languages and make these very good dynamic web pages with it. You got a lot of good open source software and hardware. A fast ARM core processor, and the black version has a micro HDMI display. It's not so hot, but it's still a display. But most importantly, the BeagleBone has built-in analog inputs. This is tremendous. This is one thing the Pi is really missing that the BeagleBone has. You know, disadvantages: your display's not as good if you look at the black versus the newer Pis. You have a single core processor on most of them, except for the very, very new ones. And anytime you have an operating system, you got this system overhead. These cost a bit more than the Raspberry Pi. You don't have the community support as much as the Pi. And I found that it's not quite as stable as the Pi as far as the operating systems and the overlays, especially the backwards compatibility across the platforms, the different versions of BeagleBone. Do want to mention real quick a more industrial version of Pi, I'll call it, and that's the NVIDIA Jetson family. It has a Ubuntu Linux operating system. You have a very powerful CPU on these. These have some graphics processors that rival some of the more advanced PCs. They're very, very powerful systems, but of course the price matches along with it. You know, $600 for the top of the line, but it has some serious processing power. But the other cool thing about it is you can actually take a hat from a Raspberry Pi and run it right on a NVIDIA Jetson. The Pi 40-pin connector is starting to become an industrial standard for hooking up peripherals. So it's a really nice option if you're looking at doing some heavy-duty processing of images or other AI type applications. So let's talk about Pi finally. So Raspberry Pi, Linux operating system, you got all your languages. You can make some really nice interactive web pages, massive open source software, some very, very fast ARM core processors, easy to implement GUIs for interactive programs. The disadvantage is, number one, it does not have analog inputs. It's definitely one thing that's missing, that if they just had it, it would help out quite a bit. It's very power hungry, especially when compared to Arduino. You know, these things really take down the power. I would not recommend a Raspberry Pi for anything that's battery powered. If anything, I would go to a BeagleBone, which takes 1/4 of the power that the Raspberry Pi 4 takes. One other thing you got to watch out for, particularly on the Pi 4s, is the operating, the heat dissipation on this is actually pretty bad. So you really need a heat sink on that. You can't enclose it tightly without a good heat sink on it. Let's look real quick across the versions here. So it really started way back with the Raspberry Pi B. It was a single core ARM running at 700 megahertz. There's some older versions, but I sort of truncated this. And we go up to the very, very latest version, the Pi 4, which has from 1 gigabyte to 8 gigabytes of RAM on it. And then the Pi 400, which has 4 gigabytes and a 1.8 gigahertz process quad-core processor on it. It's a very, very nice system and very well integrated. So if you look at your benchmarks, you go way back to the B, and you can see the performance increases dramatically as you get to the Pi 4 here. You can see that you're multiple hundreds of times the power of the previous versions. So they've come a long way as far as the processing power. So these are some pictures of the Pis. So let me just drop out of this real quick. There we go. Stop sharing. Okay. So I just wanted to show you a couple of Pis, and this is the Pi 400 kit. And the nice thing with the kit, comes with everything you need. This is, of course, the keyboard, computer, and all your connections are right there on the back. In the box, there are a few items, and that is the power supply, mouse, and an SD card with an image of what you need to operate. And then below all this, a nice little manual on how to get started and how to run it. So it's a really nice setup. It's a long way from the original Pi B from about 10, a little over 10 years ago. And this is what I started off with on Raspberry Pi. So just curious, what sort of Pis do all of you have there? Why don't we start with Garrett? What type of Pi do you have?
I have a Pi 3 Model B.
Okay, cool. That's a good one. Josh, what sort of Pi do you have?
I have the Pi 0W and the Pi 4.
Ah, cool. A nice small W. So
Yeah, really tiny.
yeah, mine just hit on me. So one of these little guys. Yeah, they're pretty cool. Okay, Steve, what do you have?
I have a Pi 4. Unfortunately, it's about 10 steps from here because the only HDMI connector I had was on a TV in my bedroom.
Okay, no
and
problem.
I've got it enclosed in a plastic case without heat sinks, but I have a fan. But you
have a fan. Okay, good.
Well, hopefully, we're not going to do any data processing tonight. It's already warm.
Yeah. No. And Wyatt, what type of Pi do you have?
I think I have a 3 as well.
Okay, so a 3+ or just a 3?
I think just a 3.
Okay, so the three's a good one. It has built-in Wi-Fi. That's always good to have, because prior to 3, you didn't have Wi-Fi built in. As far as the bigger boards, only the 0W had Wi-Fi. So, okay, very good. We'll get to some fun with Pi in just a few minutes here. So some good resources for Raspberry Pi. First of all, raspberrypi.org is the foundation that has developed this platform. And they do a good job on keeping their websites up to date as far as the latest versions, what's current, what's going on, and tutorials on how to do things. This is also the best source of the downloads of the images. They have some really nice tools. We'll show you the tools there that they have on that. Another good site that I've been using quite a bit for comparisons is Tom's Hardware. That's got some really good reviews on not just Raspberry Pis, but all sorts of Linux tutorials about different systems and so forth. So it's a really nice website. And of course, Adafruit has one of the better sites for Raspberry Pi. SparkFun is one of our local companies here in Colorado. They're just over here in Longmont. And one nice thing about them is they, their inexpensive shipping comes very, very quickly here in Colorado. You can get it the next day. And before the pandemic hit, you could actually order it and go in 2 hours and pick it up from their storefront right there in Longmont. So it was really nice. Newark Electronics, Newark.com, currently has the, I'll call it the contract for selling Raspberry Pis in the United States. So they're what's called the prime source for Raspberry Pi parts in the United States. So typically they will sell you the Pi at the online price or the list price, and that they will they never go up because of demand. So it will be whatever it is. They're the primary site for the United States. Micro Center actually has a store here in Denver. They have a very good selection of Raspberry Pi that you can actually go down there, look through the store and see the different things they have in the store at a brick and mortar store. And also, of course, you can buy online. You got Indestructibles, How to Raspberry Pi, lots of great tutorials. And of course, two other good sources is one is this class, which is on GitHub. I will be adding the link to this video on the GitHub site, so you can go to that as well. But that's where you can find all the code that I'm going to go over in this class and this presentation. So it's all up there. And of course, you can always email me at my email address about Raspberry Pi questions. Now let's start looking at our Raspberry Pi. Some really, really important tips. Don't add or remove hardware while running, including heavy loaded USB devices. This can kill your SD card. I have unfortunately killed enough SD cards to know that, just hooking up that one wire, to your, particularly the header, or plugging in that big heavy loaded USB device can cause the power supply sag just at the wrong second and corrupts your SD card. And if your SD card gets corrupted, you might have to rebuild your entire system. And of course, the best way to power down your Raspberry Pi is through the software command. You can either do it by GUI on the screen or sudo power down that will both power it down. Because the SD card, when it's writing and the power goes down unexpectedly, it can corrupt it. SD cards are fragile and wear out. Keep a backup. It's essential if you have especially a big project you've been working hard on to make a backup of it. The good thing is they've made it much easier in the past few months to make backups of your system, and we'll show you how to do that. The SD cards come in various speeds and sizes. The class 10 card is the fastest, and this is what you want to use on the Raspberry Pi. For Pis older than version 3, the 2s and earlier, the maximum size was an SDHC 32 gigabyte, and that was because of the style of formatting in the SDHC. For the newer Raspberry Pis, you can use the SDXC, and that's actually fairly new, but now you can use the bigger cards, so you're not as limited on the space anymore. So this is a nice new addition that has come out. The Raspberry Pi ports are 3.3 volts. If you put a 5-volt signal on there, you will probably render the port and possibly the whole Pi useless. I have personally popped a couple ports and had to just throw out a Raspberry Pi because those ports were dead because I put a 5-volt signal on it. So lesson learned, watch out on 5-volt signals. Also, SD cards sometimes pop out. If it pops out, go, okay, don't try and pop it back in real quick. Resist that temptation. You'll make it even worse. Just unplug it, plug this SD card back in, and cross your fingers and hope that it works. Over the years, the versions of Raspberry Pi have come out that are newer and newer. They have names. They started with Wheezy, went to Jessie, Stretch, and then Buster. So the latest one out is called Buster. These are all characters from Disney's Pixar Toy Story. So that's where these actually come from. And the nice thing is, as the newer versions come out, they're backward compatible with all the old systems. So you can run the latest, greatest Raspberry Pi code on the Pi B Plus, you know, from way back, or even the Pi B. So this is a really nice feature that Raspberry Pi has gone out of their way to support, is the backward compatibility. So if you do something on a Raspberry Pi 400, it actually still works on the older Pi. So your SD card is transportable to a point, as long as it's not on a SDXC that's not compatible with the Pi 2s, and I think also the zeros they're not compatible with. So that's the only caveat there, is the actual SD card, but the code is compatible, which makes it very nice. How to download the code. So we're starting to get into it. So
Hey, Chuck, just to
Yes.
thank you for spending time with the students last night. I'm in and out of the meeting, so I just stopped by super briefly. to
okay,
say
no
hi,
problem.
To see how everyone is doing. Have fun, guys, and Chuck is an awesome guy. He'll be able to help you with everything.
Okay, thank you,
I hope
Oliver.
enjoy it. All right, see you. Bye.
Okay,
Thanks,
bye.
Chuck.
Okay, so they made it very, very easy. If you go to raspberrypi.org software, there's 3 different download sites you can click, depending upon if you have Windows, Mac, or an Ubuntu system. You can click on a link and download the image burner. Once you've downloaded that, what comes up when you've run it is you get to choose what operating system you want to burn to the card, and then select what card you want to burn and hit write. And this is very much like the older tool that was out there called Etcher. So Raspberry Pi is sort of taking this over, but instead of having to go out to their site and download, what this does is it goes out and downloads the latest version for you from the internet and writes to your card directly. So you'll get the latest version by doing this. There's several different versions out there to select from, including some advanced Ubuntu 64-bit versions, but those only run on the Pi 4s and the Pi 400s. But some really nice new features that Raspberry Pi has put on their system. So now if you look at the connections on your Raspberry Pi, there's typically 2 primary connections you need to worry about on setting it up, and of course your USB for your keyboard and mouse. So what you want to do is hook up your HDMI and your USB devices first, then power up the system. So you always do the power last on the system. And then of course the better way to go is, once you've powered down the unit, remove the power first, then all the other peripherals. On the standard credit card size computers, there's a jack on there that has the audio output. And if you have yet a 4th contact on it, you can actually get NTSC or PAL video on that if you're not using an HDMI. So let's, if you have a Pi, why don't you round up your system, plug in your cables, get your USB mouse, and make sure that you're coming up and getting in a good state for doing some interactive exercises here. And once again, if you need to power off your system, it's best to use the GUI power down or sudo power off. One other thing you might see on the upper right-hand corner of your screen is a little lightning bolt. If you see that lightning bolt, it means your power supply is a little low on power. So watch out for systems that have that. It may be a power supply that doesn't quite have enough current for that Pi. So most of you have gone through these screens already, but on first installation, these are the dialogues that come up on installation. There's a couple of key things you want to do. First thing is you want to make sure that you set up for a United States and the US keyboard. If you have the default UK keyboard, you will find a couple of keys don't match when you type. If you type the Shift 3, instead of getting the hashtag type symbol, you actually get the English # symbol coming out on your display. So watch out for this one. This is a key one that has driven me crazy a couple times when I forgot to get the keyboard right. The other thing is change the password. Change it to something that's meaningful for you. It may be simple, but do not leave it at Raspberry. There are many bots out there in the world that just search for Raspberry Pis, and as soon as they see one, they use the use the default user Pi and the password of Raspberry and try and take it over. And they will take it over very quickly in certain places. So this is one thing that absolutely on a Raspberry Pi, do not leave the default password or you will be hacked, particularly if you're on any sort of system that doesn't have a firewall preventing hackers from getting in. There's a little screen set up. When you look at your screen, if you have black borders around it, you check the box, otherwise you leave that open. It has to do with, there's two different modes of HDMI that come up on monitors, and this is something that you can also change later. One thing that's sort of nice to do is to connect up to a network. This way you can get the latest software. If you have it wired, you can skip this step. If you don't have it wired and wireless, it's best to connect to some network to get all the latest updates in the system fully set up. A couple more things on the operating system. If you hit the next on this one to do the software update, it will take about 5 minutes, but it's well worthwhile because it will get you all the latest package locations, especially on where things are located. And this will take about 5 minutes to do all of the downloads. And after that, your system is up to date and you're pretty much ready to go. And you can hit restart to get the system going. Now, after reboot, and this is where you guys can take a look at your desktop. In the upper left-hand corner, there's a little Raspberry Pi. There's preferences, and then Raspberry Pi configuration. And that opens up this new dialog box here. So the first dialog box shows how it boots up, whether there's a auto login or not. You may not want it automatically logged in, or you may want to just dumb terminal looking command line interface to boot. And you can have it where it logs in or not. There's, depending upon your system, there might be a power LED, a single power LED, which you have a choice between activity or constant for the power. Some more things on the configuration. Overscan is basically if you want it to go a little bit further out, it's best to leave this one alone. Pixel doubling is if you want to make your, basically 1 pixel counts for 2 pixels, so it's actually a much lower resolution screen. This is something you might want to use if you have a very big screen and you want people to read it at a distance. That's the only reason I can think of that. And then screen blanking is if you want it to go to sleep when the screen when it's idle for a while. This next page is one that has a lot of detail and is also very important for how you want to set up your system. So the first one is the camera. If you have a camera, you want to enable it. If you don't have a camera, just disable it. It will save you a little bit of system overhead. The next line is called SSH, or a secure shell. This is something that you want to enable if you want communication between you and the PC using some of the tools. Also, there's another tool called PuTTY that you can log in with a remote terminal. This is a very, very handy tool, and secure shell is a good way to move files and provide communications over the network. VNC is a handy tool. It's built into the Raspberry Pi. Thanks to Real VNC, they actually include it free with Raspberry Pi. And this is a really nice feature to have, to be able to basically remote desktop to your Raspberry Pi. If you're inside the network, it's very, very easy. You don't need to sign up for anything, and you can just go look at your Raspberry Pi on your network. But if you set up an account, you can actually do it from anywhere in the world. And we'll show you a little bit of that later. SPI, this is one of the fastest serial interfaces. My suggestion is to enable this SPI bus, and this will allow you to do the faster captures. For example, the ADCs, if you want to put an audio ADC on your system, you definitely want to use that. The I2C bus is one of the more ubiquitous systems used for many, many peripherals. This is one that if you're doing any hardware, I2C is probably going to be one of your most common ones, and you'd want to enable this. Serial port, this is a very nice feature to enable, because this gives you a nice serial port for communicating to many things. And what I like to do is disable the serial console. So what happens is if serial console is enabled, it's like you have a serial terminal into your Pi, and this takes over that port. It's nice if you want to have a serial terminal to your Pi, but it's not so nice if you want to control something like a GPS, because then you're sending up to your GPS all your information from your Pi. So it's something you don't want to have. One wire is a single wire GPIO. It's not as common these days. And then remote GPIO is something that is new, that you can do remote control of your GPIO. You have another opportunity to change your location and time zone. This is something that I would encourage you to set it for where you're at. Otherwise, some things get a little funky as far as when you look at the time. You don't want to look down and go, why does it say 4 o'clock in the afternoon when it's actually only 8 a.m. here? So anyway, another really nice thing is the GPU memory control. If you have one of the newer systems, particularly the Pi 4s, you have 2 gig of RAM at least, then you can up the amount of memory on this. This will give you much faster response, much better graphics on your system. I like to kick it up to about 256 from 64 as the default. There's also a nice little GPIO pin you can enable for the fan. So you can actually click this to enable the fan, tell which GPIO the fan is on, and at what temperature to turn on the fan. So this is a really nice addition for those of you who have a case with a fan. You can actually enable this feature and control the temperature. Okay, let's get into some useful tools. Top of my list for useful tools is another Linux system, believe it or not. And this includes a Mac. It makes things much easier as far as exchangeability of the commands and understanding how to do the commands. If you know all the Linux commands, it translates very nicely to the Pi. And then if you know all the console type commands on the Mac, you can do the same things. There's a lot of Mac underneath is actually a Linux. iOS is really a Linux. So you can use a lot of the commands that you use on the low-level Mac that on the Linux system. One tool I have used heavily in the past is WinDisk Imager. This is an offline copy system to copy your SD cards. So what you can do is you can power down your Pi, pull it out, make a backup copy of your Raspberry Pi image onto your PC, and then put the SD card back in. And this way you can keep a backup copy on your PC, which is really nice. Putty is a nice console that you can go to a Linux system. You can have multiple Putty windows open on the same system at the same time. So this is nice if you're a command or command line jockey. That makes it really nice to work with. And Putty's a really essential tool for this type of work. VNC and Real VNC. This is a way we can remote desktop. Well, I'll show you a little bit more. And then the other thing is make sure that you have your good USB power of 3 amps and more. You know, a lot of particularly the older computers were limited to 500 milliamps. That will run a Pi 0, but it will not run some of the newer Pi 3s and Pi 4s. So you definitely want to have the good external power, particularly the power supply that comes with the Pi is the nice ones. So I want to show you real quick the VNC remote access. So I showed you how they enabled the VNC in the setup a few slides ago. What you can do is you can hover over your network symbol to find what address or addresses you have for your Pi. And then if you have your VNC enabled, you can download your VNC viewer for free and connect to the unit locally via VNC. So let's see here. So that's what I have going on here. So this is a VNC on one of the Raspberry Pis. So I'll actually close that one down and go to, this is the dialog. You just put in the address of your Pi and type in the password you set up. And if you get your password wrong, it says that. And if you get your password right, it comes up with a copy of the desktop you have going. So it's a really nice tool to have the remote desktop, so you can work on your PC and have a window into your Raspberry Pi and see both. You can also cut and paste between the VNC and your PC. That becomes very handy. This is a really nice way to work with. If you want to connect from anywhere, this is where Real VNC actually has some limits on this. For non-commercial uses on Raspberry Pi, they have a Raspberry Pi edition here that is free, but you do need to sign up for it. You do need to sign in. But what happens is once you set up an account, you can have up to 5 Raspberry Pis, and you can talk to them from anywhere in the world, literally. So what you can do is you actually have your Pi up running somewhere. As long as it's connected to the internet, you can actually remote into your Raspberry Pi from anywhere in the world, literally, and work on your Pi. Once again, it's for non-commercial uses. The Real VNC company is trying to, entice you into this to use it commercially, of course, but for the Raspberry Pi enthusiasts, this is a real blessing. So use it while it's still out there. I've used this quite heavily with my Raspberry Pi work. Another real useful tool. This is particularly between your Windows PC and your Linux systems, any Linux system for that fact. WinSCP. WinSCP is a nice GUI tool that you can copy files between your PC and your Linux system, and also edit them. So this is a really nice tool to have. So once you have it up, you can log into your computer, your Raspberry Pi, you set it to SCP and put in the host, that's that address that you had, and put in the username of Pi and the password you created. And then once you have that, then you have the WinSCP dialog that you can actually drag files back and forth, right click and edit files directly from this GUI. So you can actually edit files on your PC with an editor that you might like instead of one on the Raspberry Pi. So this is a really handy tool. A couple other tools I mentioned, PuTTY. This is what the PuTTY might look like on a system, and then the WinDisk Imager. Like I said before, back up your files. Also, one thing about SD cards, they're not all the same. When you try and write to an SD card, you might find, oh, it doesn't have enough space. And when it says 16 gigabytes, it might be 15 gigabytes in actuality. There's bad sectors on a lot of SD cards. So beware of not all are the same. And when you copy one in, you need to have the same size or bigger SD card when you copy it out. Now here's the new tool. This is really cool that actually came in, I think last year. This is the SD card copier. This is actually on your Raspberry Pi itself. If you have one of the newer versions, go over to the Raspberry Pi logo, accessories, SD card copier. And what you can do is you can actually, using a USB to SD card adapter, actually back up and create an image of your SD card while on your Raspberry Pi. So you don't even have to remove your SD card to make a copy anymore. Just a few cautions about this. One is copy from the MMC BLK0. Never copy to that, otherwise you'll overwrite your system and the system will crash. And also, one other very, very important thing is, while the copy is running, close all the other applications and don't make any changes to the file system as it's making the copy. Just start off the copy, go away, and once it's done, it will say done and come back. And this is a really nice tool because once that copy is made, it's a live version. You can actually put it in another Raspberry Pi and start going from there. So it's a really, really nice way to make backups of your system and keep your work so you don't lose it. Like I said, SD cards are very fragile, and I would keep a couple of SD cards around just so you can back up your project once you get major changes done. Some other really nice things that you'll find on your desktop there. When you look at the Raspberry Pi logo, there's a little thing called Office. And you see these LibreOffice typically on there. If you don't have it, you can always load it. But the LibreOffice Calc is basically like Excel. You can actually export to Excel files and read Excel files and do a lot of the things Excel does. It doesn't do the macros like Excel, but does the basic calculations like Excel. It's a really nice to have. Office Draw is very similar to Paint. Office Impress is effectively a PowerPoint. You can read in PowerPoint slides and use that. Office Writer is basically your a Word document. Office Space is like Microsoft Access. It's a database system. And then the Office Math does the equations. So this is a really nice set of open source tools that are free to install. You don't have to pay any subscription fees for these tools. It's a really, really nice addition to the system. One very important tool to know about is, of course, the terminal window. This gives you the command line console, and there's a little console symbol up there. You just click there once, and a screen should open up. So there's a lot of different Linux commands out there. LS is sort of the directory listing. CD is how to change directories. DF, and I particularly like DF-H, tells you how much space you still have on your system. And this is very useful if you have a smaller SD card. You can see how much is left. Nano is a very simple, intuitive text editor. This is a text editor that you can look at and figure out how to run. It's a very nice editor. And if you're not very familiar with text editors, this is the one you use. VI is a simple but powerful text editor, but it's not intuitive. I've used this for many decades. This is the one I use, but I would not expect a beginner to work on this right away. It takes some time to learn the commands on this. Some basic other commands: cat is list the contents of a file, less is list the contents of a file, but one page at a time. And then we got these apt commands: apt install, this is how we can get a package; apt update, we can update our system; and apt cache show is to show what package might be available, which brings us to how to install software packages. So if you're trying to look for something, apt cache search and then the name of the package you might want, like apt cache search Java 8 will show you all the things that might have Java 8 in it. If you want to install a package, you must install it in an elevated mode. To do elevated mode, you do sudo, which means substitute user, and do the following command. So substitute user in this case means root. So you elevate yourself up to some a level that can do installations, and then you install a package like Octave or Python pip or something else. There's also some other package installers. There's pip, which is a Python package installer. This is a very a basic system for installing Python packages. Then there's some other installs that they have for easy install. This does a lot of really complex installs that have compilations and so forth. And they've done some really good things around easy install. This is something that is not as used much anymore, but you might see it on occasion on a package. And then of course, another way to get software is git space clone, and then the package that you might want to get. So it's actually fairly easy to do, and we're gonna do that here in just a little bit. So let's, so if you can, let's do a little bit of an exercise here. So we're gonna install a package. So I'm gonna do a apt search spice. Whoops. Apt cache. And this is going to list me all the packages that have spice. In this case, spice is, we're looking for a schematic capture and simulation tool. And if I look closely, there's a package called oregano. Oh, I want to install oregano. So I do substitute user, do apt install. And one nice feature on the Linux systems, if you highlight the word and then center click your mouse, it will actually do a copy paste for you. You don't have to do a Control C. You just highlight it and center mouse click. So I hit that and it goes out there and it finds the package and says it's 2 megabytes of additional or 12 megabytes of additional disk space. Do you want to install? Yes. And it takes a short amount of time to do the install. And once it's done, I will then have a new program available to me called Oregano. Just a second here. Now, when I look up here under education, you can see oregano. And if I bring up oregano, you'll see it's a nice design automation tool where I can put in a drag and drop a capacitor, draw lines, do simulations and everything. So it's a nice free tool. It's not your fanciest SPICE simulator, but if you want a quick, easy simulation of basic transistor circuit, it's a nice tool to just install onto your system, and you can see how fast you can load it. Oops. Now, there is one other way to do this. I must admit, that's the command line way to do it. It gets a little tricky with the apt-get, but you can go here, preferences, add and remove software, and then search on something like Octave, and it will find it. But this one is, I find a little bit tougher to sort through what I really want to install or not. So it can be quite long and not quite as easy, but at least it is a GUI method of doing this as well. So that's another way to do the install. Now let's take a look at how to get software from repositories. And this is where you can download, whoops, just a minute, I gotta get my camera back. There we go, sorry about that. This is where we can get code repositories from all sorts of open source sites. So one of the easiest ways to get this is if you go to the web browser and you go to a GitHub site, you can see, oh, here's some code I want. This guy's got some good code. It has all sorts of good things in it. And I want to download it onto my Raspberry Pi. And you can get all the code all at once. So what you do is you can click this code button and then click this here. And what this does is it copies it to your clipboard. And then you go git clone. And then remember that center mouse button? That's the button you press to get what's on the clipboard. And then you hit that and it will download that version of the repository to your Raspberry Pi. So if you guys can do that while I talk here, I'm gonna talk a little bit more and we're gonna use some of the code that's in this repository. Okay, so once it's done, you'll see this come up and say, I have it downloaded. Once you've had it downloaded, you change into that directory, in this case, the CSU PI class. And if you want to get the latest version, yeah, say I make a change and you want to see, hey, has he made any changes lately? You say git pull. Pull is pull from the repositories. So this is a way to get the latest updates if you have anything in there. You can also go git space status, and that will tell you the status of the stuff you have in the directory, whether you've changed anything or there's new versions available. GitHub is a great collaboration tool for open source projects. It's free. The size limited is 500 megabytes these days. It was 1 gigabyte and they knocked it down to 500. No single file bigger than 100 megabytes. So it's a little tough to save images of Raspberry Pis up there. But you can easily start a repository, control it, and who can change it. You can have your classmates or anyone be able to change it. You can set up all sorts of branches and tags, and more importantly, keep track of who's changing what, when they changed it. And if you have to, you can go back. You can go back to a previous revision very, very easily, particularly if some code is not quite right. You know, you can go, oh, that wasn't quite right. I can go back on this. You can do private repos and closed repos, but they may require a monthly fee if you do some closed repos. Those are repos that are not open to the rest of the world. So most of the repos are open to anyone that wants to search on them, but you can close them if you want. It's a great way for collaboration. If you have more than one member of your team doing code, it's a marvelous way to keep track of everything and changes. And even if you're just a single user like I do on a lot of things, it's great because I have a place I can always know I have my code up there. I have a tracking of it. And if I need to download it on another machine, I just go clone and get that revision. And I can also make releases to say, okay, this is a release that has these tags on these files to say that's a release. All of these files work together in conjunction, and also have, you know, while still having other changes going in, you can actually have it so that you have the release, but yet can be updating code like crazy, and the people pulling the release won't be affected by those new files on the system. There's a nice intro class on Coursera. It's offered by Google called Introduction to GitHub. It's a nice little class if you're interested on GitHub. This is another nice little tool you might load on your Windows desktop. It's called GitHub Desktop. And this has a lot of the controls that you might need for you know, looking at your system. And you know, on the Windows-based system, this really flows quite well. The only issues that I've had is Windows likes to put in extra characters sometimes on certain text files, and that has run into some interesting problems. But other than that, it's a good way to go to also have all your code available to to look at the status and do updates on your PC or Linux desktop as well. So hopefully you've gotten the GitHub code downloaded by now. So if you have, we're going to look at a programming IDE. So you can program one of two ways. You can do editors and then run the code, or use an IDE, an integrated development environment. And Genie is a nice one that Raspberry Pi offers. So let's try the first program. So what I'm going to do here is I'm going to go to Programming, Genie, and this is going to open up this GUI here. And what I'm going to do is go File, Open. I'm going to go to CSU PI Class. Oops. I did one too many clicks. Open. CSU PI Class, and I'm going to go helloworld.py. And I'm going to hit Open. You can see this is a very, very basic Python code. It's basically a for loop that prints out hello world for 10 times. And to run on Python, it's quite simple. You just click the airplane, which is run. And you get another little terminal that pops up with the output of the program. So this is very nice. And if you want to change the number on this, you just change the number, hit run, and now it's 12. So it's very, very simple to edit and run your code. For C programs, they're a little bit different. So we'll open a C program that's basically the same thing. It does a hello world 10 times. On C, however, you have to run the compile, and this basically checks all the syntax of the system, run the build, and this links in all the other libraries into the system that are required. In this case, standard IO needs to be linked in, and that's why we need to hit the build. And then we hit the run, and once again, it comes up with hello world 10 times. So very similar thing, but you can see it works quite well. This also works in several other languages. I found that I believe it even opens PHP, and I think it will open this. Yes, it will even open a HTML. So if you're writing in PHP or HTML, it will also open those as well. So you can actually do many different languages with this nice IDE built into Raspberry Pi. So hopefully you've had a chance to play with a couple of those. I will use a little bit more on this later. You go back to our presentation. So let's talk about Raspberry Pi IO. We got a lot of really cool stuff in this one. You know, we get the general purpose IO. That's basically turning a pin high or low, or reading the high or low of a button or switch. So this is really good for controlling LEDs and relays, etc., and looking at buttons. The UART serial remember it's a 3.3 volt interface, so watch out. Some interfaces are 5 volts. Definitely one to watch, because I've had some problems on a more powerful RS-232 device that burned out the lines. Baud rates are up to 15,200 practically. It can go faster, but really 15,200 is where you should run it. There's the SPI bus. There's the 4-wire interface. This goes up to, on the Pi, of 125 megahertz. The default is 1 megahertz. So watch out if you got something that needs a slower clock speed, you will need to change it. But this is a super fast interface that can easily run some of these smaller LCD screens. So it's a good way to put on these smaller LCDs onto the system. The I2C bus or I2C, is a marvelous interface that can connect up many, many different devices, all at the same time on this same bus. This can be used for thermal sensors, atmospheric sensors, all sorts of different sensors. It's a much slower speed, 400 kilobits per second on the Raspberry Pi. And typically the I2C doesn't go any faster than 400. So you can see that it's much slower, but you can have many, many more devices on the same bus. So it's a marvelous interface. And if you're looking at devices, this is probably, if you don't need to do it quickly, this is probably the interface you want to use. So let's look at the GPIO and GPIO interfaces that's built into the standard Raspberry Pi system. It's actually not too bad. So actually I need to go to the other Pi. Just a second. All right, I need to go to this one. Another Pi. One handy command is called pinout. You'll see why I switched over to this screen. So pinout is a nice graphical text produced screen that you can look at and understand the pinout on your Raspberry Pi as to what port is on what pin and the configuration of where everything is at. You can see it has a little diagram of the board. It gives you what device you have here as far as the revision of Pi, how much RAM you have, etc. And then it has a nice little graphical interface of all your GPIOs. So this is a handy little interface for looking at your GPIOs. Now, if I want to control those, there's another set of commands called GPIO. And to look at the state of everything, I go GPIO read all. And this gives me a nice diagram of what all the pins are, what the current reading is of that pin, if it's a high or low. So you can see very quickly, is this signal high, is this signal low? And then if I want to change one of the GPIOs, what I can do is I can first set the mode to what it is, whether it's an output or an input, and then I can write it to a certain state. So let's try the example. So if I go GPIO mode, and I'm gonna do, and this is where you got to look at the column here. This is what's called 7. So I'm going to go pin 7. I'm going to set for an output. And I use an up arrow, and I'm also going to do 0. which is this guy. And I'm gonna do my up arrow again, do 2, and then do up arrow once again, do 3. Now I'm gonna write to those pins, GPIO, right, pin set or GPIO 7 to a 1, and I'm gonna set 0 to 0. I'm gonna set 2 to 1, and then 3 to a 0. Now, if I up arrow to my GPIO read all, now you can see my 7 is 1, my 0 is a 0, my 2 is a 1, and my 3 is a 0. So you can see it's very easy to write these GPIOs into whatever state using the built-in GPIO commands. This is part of the standard release of Raspberry Pi. There is one caveat though, just a second. For the read all to work on the on the Raspberry Pi 4, for the Raspberry Pi 4, a new version needs to be downloaded, and there's a link for that. So you do this wget in this project, and then sudo in this command. So this will get you to the point where your read all will work. The GPIO will work, but this is the way to get the latest version that works for Pi 4. Okay. Now you can also do one other nice thing here. You can do these commands in a script. So in this case, it's called a bash script. So I have in the very, very first line of this file, I have what's called a shebang. That's this # bang /bin/bash. That means I'm using bash to run this program. And then I can actually write a small loop and actually toggle a pin just by using this command line program to go high and low. So every second it goes high and low, and it will just sit here and loop until I hit Control C. So this program is also included in your system. One other thing you might want to know is there's 2 different naming conventions within the Raspberry Pi. There's the GPIO/wiring Pi versions, and then there's the BCM version. If you're ever needing to use the BCM version, all you need to do is add in a -G before the rest of the command, GPIO space -G space, and then the command, if you're using the BCM notation for your GPIO. All right, on to some other fun things you can do. One really nice thing to use the Raspberry Pi for is as a wireless access point. Why do you want to use a Pi for an access point? Well, this way you can control the network traffic. You can measure the network traffic. For example, if you're trying to do some performance measurements of how fast you can transfer over a wireless network. Also, you can control where the network traffic goes. If you see a certain website, you can actually redirect to a different one. You can act as your own firewall. One other interesting use I've seen of using this is as an ad blocker. It actually, you get this list of ad sites that it will actually block from any system from accessing. So you won't get these annoying pop-up ads or additional ads on your devices that are using this as the access point. So it's a handy little thing to use and set up. So it's something that as you advance further in your careers, you might find something like this very handy to have ultimate control of what goes out over the network. Some nice hardware you can add on. There's several USB type hardware. One of my favorites is SDR radios. This way you can actually receive AM, FM, single sideband, aircraft squawks, and satellites. You can add on, of course, GPSs to get precise time and location. I have a good friend that actually uses Raspberry Pis and a GPS to be their local time base. And he actually has his system, his entire network down to microseconds of time between the standards by using the GPS control. Of course, over the USB, you can also control instruments. There's a whole set of skippy commands that you can issue through Python and actually control meters, oscilloscopes, and more just by using the USB and controlling the devices. So you can actually make a little lab controller. And of course, you can also connect, program, and run Arduinos. This is another nice thing. You can actually have Arduinos and Pis working together where you actually get input from Arduinos and also be able to program your Arduino from your Pi. So you don't have to go over to a PC to change the program. Some nice other features are the DSI interface. This is the way you can connect up a camera and a display. So this is a really nice camera, very easy to hook up, and you don't use a USB port. It's actually much faster as far as the interface. And of course, the display gives you a nice touchscreen, 7-inch for very low price. And of course, the 40-pin interface. This is the best way to get your DACs and ADCs. And this is really the best way to get in your analog is to add on some sort of hat. You can also get control boards for relays, LEDs, and signs. And you know, there's a few crazy people that use it to control breweries. So let's take a quick look at this guy here. So this is basically the touchscreen interface here, and this is really nice because you got the touchscreen and a camera all built in together. And so now if I share my screen again, and I'm gonna go over to my, fortunately it dropped on me. So this is that same touchscreen I have in my hand, and now I will fire up the camera here. So You can see my camera is running on the touch screen here very easily. One interesting thing with this camera was at the hackathon last year at down at CU. One team took this camera and turned it into I'll call it a facial recognition system that would recognize a person and then tweet that they saw that person. So it's so you can easily do some facial recognition to figure out who's out there and do action on that. So it's a really nice touchscreen case, and you can see the camera is a very simple ribbon cable, and I believe there's the Pi Zeros actually have the interface for that camera, so you can actually hook on your little camera and basically have a little spy camera with a Pi Zero out there. So nice little addition. And the camera also comes in a no IR, which does very well in the dark. So if you are after something in low light conditions, you use the no IR version. You won't get good colors with that, but you will get good performance in low light. Just to show you some things you can do with the software-defined radio and the USB dongles. This is the RTL SDR dongle. It's one of the better ones. It has a nice SMA connector on it, and it has a very nice software-defined radio on it. And as you can see here, I have a program called GNU Radio, where I have an FM receiver going here, where you can see the different tracks of the different FM radio stations that I was receiving. And you can see down the center is the classic FM signal. And then to either side of these signals, you can see these two bars. That's the HD. So that's the FM HD signal. You can see a faint one sort of next to this that doesn't have the HD tracks beside it. That's a conventional FM signal, but you can pick out the HD signals very easily, and you can just use the SDR radio to tune to where you might want to go. Just adding on to the GNU radio, this is a slightly different SDR. This is a little more powerful one called the Analog Devices Pluto. This is a really nice device. And in this case, one of my friends, John Kraft from Analog Devices, set up a little 10.5 gigahertz radar test range where he could actually measure and look at the squint angle of these patch antennas on this system. So you can actually use it for very complex type setups. You know, although this is version 0 with the hula hoop, but it's much more improved now. But I sort of like this version because it sort of shows, you know, some of the fun hacking you can do with the Raspberry Pi. These are some hats for the Raspberry Pi that you might have. On the smaller hats, really for the Pi Zeros, they're called bonnets. So you can see you can have many different bonnets to put on. You can make a nice little audio DAC or have an OLED display or something like that. And this case, here's a double stacked hat, and this was used to control a brewery. in particular the chillers of the for the fermenters to keep the beer at the correct temperature. And this was used for quite a few years at the periodic brewing site. And you can see this actually has two hats that take in, each hat takes in 8 channels of analog, and then has 16 channels of relay control to control relays on the system. So this is the sort of things you can do with the hats. So let's talk about another hat, and this is a very standard one that's out there. And if you're at all experimenting with Raspberry Pi and want something that has a lot of nifty things already built into it, that you don't have to solder or anything like that, the Raspberry Pi Sense Hat is perfect, because it also has a set of Python libraries that come with it that make programming this very, very simple. So I'm gonna do this for a second. So this is what the Sense Hat looks like. It just goes right on top of the Raspberry Pi here. And what I'm going to do is share my screen. And I'm going to go to this guy here. Oh, no, that's right. It's Genie. So I'm going to open excel.py. Okay, so this program is a very basic program using this Sense Hat. So you can see it's very simple. First, on the Python, you import the APIs. So this is how we do this from Sense Hat, import Sense Hat. I want my time just for a delay. I set up the object, and then I set up a loop that runs forever. I get the X, Y, and Z coordinates from the accelerometer. I do a little bit of rounding on it to make things nice, and then I print them to the screen. So what I'm going to do is hit run on this. And I don't know if you can see my camera, but as I move this around, you can see the different accelerations. One is, of course, gravity. This one's a little bit off in the gravity. It's a little over 1. Either that or there's particularly heavy objects around. And you can see if I shake it around, I can get some readings that are, a little bit high. But that's the idea. Very, very simple program to do the readings of the accelerometer on this system. Now, if you take this to another extent, you can also use the accelerometer to detect the tilt of the system. Unfortunately, it does not come out as well on the screen, or the camera, I should say. But what you can do is you can actually make a little diagram of a maze and make a little game out of moving the ball around until you get to a goal. So I will pop back over to my system here. Go to Chuck Maze. So now what you might have a tough time seeing is on my screen, I have this little ball I can move back and forth. And then if I move it all the way to the end, I get a little message, you win, coming up on the screen. And it's a nice little easy game you can make using the accelerometer and the display on the sense hat. Let's talk a little bit about GUIs. One really nice thing with particularly Python and Raspberry Pi, there's a lot of very good applications. You can build up some really impressive GUIs. One of my favorites called TK-Inter. That's where I've written a lot of programs. Matplotlib is a very nice, easy tool to do graphs of waveforms and signals. It's very intuitive, very quick to plot. TK-Inter is more for buttons and setting up actions, whereas Matplotlib is really geared towards putting out graphs. Another one is called Pygame. It's a lot better for doing sprites and other things. There's a couple other standards like GTK and Qt. So there's a lot of really nice tools out there to do these nice GUIs. I'd like to show off one other GUI that's also using the sense hat, and that's using my paint program. You'll see why I like this. Where did it go? Oh, it run. Okay, so what I got here is a big TK-Inter GUI, and it has these 64 buttons in the center set up in a grid, and it has these color pickers off to the side and some scroll selectors here and some other buttons. So what I can do is I can pick one and start drawing at whatever I want. If I don't quite like that color, I can change my color a little bit. Let's add in a bunch of green, maybe a little blue, start drawing with that. And then I can load and save something that I like. For example, this is something that I created a nice little rainbow on to just as a demonstration. If I want to change a color, I can just click it over here, go there. And if I want to, yeah, so it's a really nice demonstration of what a complex TK-Inter system would look like. So it's something that if you want to get into it and look under the hood, the program's out there on the site. Okay, let's look at one last thing here. The I2C bus. This is something that if you're hooking up a device to your Raspberry Pi, this is the way to go. I will go over to this Raspberry Pi again. The basic commands are I2C detect. Then -Y makes it so you don't have to answer any questions. And then I want to look at bus 1. So on bus 1, I see I have a device at 1C, 5C, 5S, 6A. So now if I want to see what's in device 5F, I do I to C dump. Minus Y1 plus 1, 0x5f. And it shows me everything in that device. It just goes through whether it has anything there or not. Now, if I want to set a value in that device, I to C set minus Y1, 0x5f. And then I want to actually change register 20 here. So 0x20. And I want to change it to hex 18, 0x or 81. And what this does is this actually turns on this device. Now, if I want to get a particular register value, you just go I2C get and the device and the register. If the device doesn't have registers, you just give it the device. And that shows 81 like I wrote. And then once again, if I use my up arrows, I can see dump. And now actually some of these values have changed. So this on the sense hat has the HTS221. This is a nice little humidity and temperature sensor built in. It's a little complex as far as the registers. I won't go into how to convert temperature, but it is a nice little device built onto the sense hat if you get one. I just got one more little slide here to go over, and then we'll hand it over for questions. And that is MATLAB and Raspberry Pi. MATLAB only runs on PC, basically x86 platforms. It's not just Windows, it can be Linux, but it's x86 platform. So that's Intel, AMD, and there's one other, but that's the only platforms it really runs on. If you look up Raspberry Pi and MATLAB, you say, hey, MATLAB and Raspberry Pi work together. What it is MATLAB has some libraries that you can use that remote GPIO to connect and run commands to control hardware. Now, for students, this comes with a student version. You can download it and use your Raspberry Pi with Simulink and control the Raspberry Pi as part of this as a block in your system in Simulink. Now, if you have your MATLAB student version, you can do this. If you are not doing this for coursework or research at a degree granting institution, this is not free. However, they now have, I'll call it home versions of MATLAB that you can control the Raspberry Pi, but you do have to pay money for. So MATLAB does not run on a Raspberry Pi, but you can run with a Raspberry Pi. And if you're doing it as part of your degree, then yes, you can use the free version and control your Raspberry Pi from MATLAB. So with that, I'll turn it over to you guys with questions or comments. Anyone still out there?
I should be all good.
Yeah, I don't really have any questions right now. I can definitely see, I might have some in the future though, for sure.
Okay, well, what I'm going to do is I will send out a link, and this is where I'll take a poll as well. So in about a week, I'll make myself available and have, you know, the pies up and running, and we can go over some things, or you might even send me what type of device you might have in advance, and I can hook one up as well. And we can go over questions and, you know, try some of these things out or try some of the code out. And if you have any questions about it, we can do that. So the real question comes in, what 1 week from now, Friday or Saturday, any votes on okay, Friday afternoon or Saturday during the day? Any votes on when a good follow-up time would be?
I think Saturday would work best for me.
Okay, yeah, I think Fridays are always tough to. So is afternoon like 2 p.m. Work good?
Yeah, it sounds good.
Should be fine for me too.
Okay,
I have to check my schedule, but it should be.
okay, that sounds great, great. So what I'll do is I'll set up a meeting for Zoom. You can join anytime. I'll just be available at that time. It won't be anything formal or recorded. And I will put out the link to you in the email, and then on the GitHub site for the Raspberry Pi, I will also include the link on the description, so you can actually go to the that link and see the recording of this session.
Thank you so much.
Okay, thank you.
Yeah, thank you.